Picture this. Someone types a question in plain English. Top 5 customers by net revenue last quarter. No SQL, no ticket, no waiting on the data team. And the answer comes straight back, a clean ranking customer A through E, but look to the right. It also shows the exact SQL it ran, a select against the governed semantic view, plain English in governed SQL, and a trusted answer out all inside one Snowflake account. Here is the moment that won the room. The same question inside a Streamlit app running in Snowflake. The chart lands and there is a view SQL toggle right beside it. Nothing hidden. The VP in the room said 2 words. Ship it then. Asked his next question himself. No engineer needed. Hold this image. By the end you will have built this exact system. And down here is the scoreboard. Accuracy 40% climbing toward 83. The request queue falling from 200 a month towards 60. Still unlit. We earn every number. Here is the scoreboard in full. 2 lines that have to move. Answer accuracy about 40% today, 83% the goal, and the ad hoc SQL queue 200 requests a month today, down to about 60, a 70% cut. We light each number up live on a real benchmark, not a slide. And here is the surprise. The lever is not a bigger model, it is governed definitions. So why does this matter? Picture the data request channel at a 400% retailer, 38 pings a week, everyone a version of. Can you pull a number? Maya, an analyst, waits 2 days for revenue by region last quarter. By then, the exec meeting is over. The data engineering team burns roughly 30% of every week writing the same shaped SQL. And leadership already pays for a Power BI dashboard nobody trusts because it is always one refresh behind. The alternative, an analyst types plain English and Snowflake writes the SQL. That is what this series builds. Here is the whole build end to end. An analyst asks a plain English question in a Streamlit chat inside Snowflake. Cortex Analyst turns it into SQL and runs it grounded by a semantic view. The model that pins down what every term means. And that model is fed by real data. The TPCH sample of orders, line items and customers, plus a file of product reviews. We build it in 2 parts. Part 1, Cortex Analyst, the semantic view and Streamlit. Part 2, a Cortex agent with DBT governance. Let's build part 1. So part 1, and start with the obvious doubt. Text to scale is not new and it mostly failed. Look at why. A generic model invents column names. It never saw your real schema. It cannot know that revenue means sum of extended price times 1 minus discount. Not just a price column. And it fabricates joins that do not exist. The fix here is Cortex Analyst, a Snowflake feature that answers a plain English question over a semantic model you author and hands back the SQL. One note before we build: verify every clause against current Snowflake docs because this surface moves. Said once. The accuracy comes from the semantic layer you give it, not a bigger model. Picture the cost of not having that layer. Before the semantic model, 3 analysts each kept their own revenue definition in their own saved query. One used extended price, one subtracted the discount, one also subtracted tax 3 different truths. So when the CFO asked for revenue, the answer depended on who ran the query that day. A semantic model fixes it. Revenue becomes one named metric, one expression shared by everyone. That is the real value, not convenience, a single governed definition of every business term. First setup, and we move fast. On screen is the reviews load, create the reviews table, a CSV file format, a stage, then copy into from the stage a few hundred teaching rows. Off camera, the same script makes the project roll, an extra small auto suspend warehouse, the database and schema with least privilege grants, and it confirms the shared sample data is reachable orders at about 15 million rows and that Cortex is on in your region. Every statement ships in the downloadable script. We are not reading DL line by line. So before any SQL design on paper, list the questions analysts actually ask. Revenue by region, orders by segment, top customers, the monthly trend. For each one, name the dimension to group by and the metric to aggregate. Then name the metrics. In business language, total revenue, order count, average order value. And write down the words analysts really use. Sales and turnover both mean total revenue. Design first and you dodge the most common failure, a model that does not match real questions. Here is the anatomy of the thing we are about to build. The semantic view, retail sales, SV, 4 parts, stack tables. The logical tables and their primary keys. Relationships, the declared joins, orders to line item, customer to orders, customer to nation to region. dimensions, region name, market segment, order date and metrics, total revenue, order count, average order value, and off to the side in amber synonyms and comments teach Cortex the business vocabulary. The rule at the bottom says it best. Define each business term exactly once here. Now build it. Tables and relationships first. Create or replace semantic view retail sales. SV, the table's block names. 5 logical tables, orders, line item, customer, nation, region, each mapped to the sample data with a primary key. Then relationships, line item, references, orders, orders references, customer, customer references, nation, nation references, region. Those reference the declared keys, so the joins are validated, not guessed. And this is the part that matters. Declaring the path is what lets an analyst ask for revenue by region, even though revenue lives down in line item. Next, the meaning, dimensions and metrics added to the same view. Dimensions expose the group by columns, region name, market segment, order date, each with a synonym list. Then the metrics defined once. Total revenue is sum of extended price times 1 minus discount, the discounted price expression. Everyone finally agreed on with synonyms, sales and turnover. Order count is a distinct count of order keys, and average order value is just total revenue over order count. The synonyms map sales and turnover onto total revenue and region onto region name. That mapping is the whole game. Stay on total revenue for a second because the definition is deliberate. TPCH has no single revenue column. Revenue is derived from line item price and discount. Extended price is price times quantity, and 1 minus discount applies the line discount. Notice what we did not do, we did not subtract tax. That is a business choice made once written down because it is a named metric. Every question for sales now uses this exact expression, and the choice lives in the comment. So the next engineer inherits the definition, not the confusion. Before wiring anything to Cortex, prove the numbers on the left. Query the semantic view directly. Select from semantic view region name, total revenue, order count, order descending. On the right, the control query. The same numbers written by hand over the base tables, joining line item to orders to customer to nation to region. Run both. If they match, the model is correct. If they do not, fix the metric expression now while it is cheap. Describe and verify before you trust and confirm the semantic view query syntax against current docs. Now connect Cortex Analyst to the view. Follow the lanes on screen. The analyst types a question into the Streamlit app. The app posts that question plus a reference to the semantic view to the Cortex Analyst API. Cortex sends back the generated SQL. The app runs that SQL on the Snowflake engine, gets result rows and renders the chart and answer and read the Amber note. The model can only reference objects in the semantic view. It cannot wander outside what you defined inside Streamlit-in-Snowflake. You make this call with the session's own credentials. Walk one question through end to end. The analyst types what was total revenue by region last year. Cortex maps revenue onto total revenue and region onto region name through the synonyms. It generates the SQL, select region name, total revenue, group by region name. The app runs it and draws the bars, America, Europe, Asia, and shows the SQL for trust. That is the first real answer. And the accuracy meter ticks up one notch, proof the loop works, not a promise. Read the amber strip, synonyms are what made plain English resolve to the right metric. Why host this inside Snowflake? Look at the boundary, everything sits in one Snowflake account. The Streamlit app object, the warehouse, Cortex Analyst, and the semantic view. All inside, only a governed URL crosses out to the analyst's browser. The app runs on the caller's Snowflake credentials, so data never leaves the account. The warehouse is extra small with 60-second auto suspend, so idle cost is near zero, and access is just a role grant like any other object, no external app server, no copied credentials. Create the app object two ways. Option A, make it in Snowsite and assign it the warehouse. Option B, on screen, create or replace Streamlit pointing at a stage that holds your app file with the main file and the query warehouse set to TTDWH. Then grant usage on the Streamlit to the analyst role. The app runs as its owner role by default. So keep that role least privilege, confirm, it can see the semantic view and reach Cortex, and verify the create Streamlit syntax and the Python environment against current docs. Here is the app skeleton, the frame we hang everything on. Import Streamlit, import get active session, session equals get active session, already authenticated in account, no connection string, no secrets. then a title and a text input, ask a question about sales, store the last question and last result in session state, kept simple, and lay down three empty placeholders, one for the SQL, one for the table, one for the chart. That is the skeleton the Cortex call wires in next. Now the Cortex call itself. Define ask Cortex taking the question and optional history. The payload is a messages list with the user's text plus the semantic view reference. ttdd byte retail sales sv. Then send us no API request a post to the Cortex Analyst message endpoint. Using the in-account helper, pass the content and return the body which carries the generated SQL and an interpretation. This is the shape, not gospel. Confirm the endpoint path and the exact field names against current Cortex Analyst docs before you rely on them. Once Cortex hands back the SQL, run it and render. Pull the statement out of the response, the line that finds the message of type SQL. Run it with session.sql to pandas in account. Show the SQL inside an expander so analysts can audit it. Then the data frame, that is the receipt, and auto pick a chart, a line chart when there is an order date column, a bar chart when it is one dimension and one metric, but always show the raw table beside the chart. Charts can mislead, the table cannot. Now fold in the reviews table. The reviews CSV is structured enough to model. Product key, rating, review date are clean dimensions and metrics, but review text is unstructured. So we keep it out of the part 1 numeric model. In part 1, reviews give us one new thing. Analysts can ask about average rating. The paragraphs of review text wait for part 2. That is the agent's job. Reading them to answer why ratings are low. Separating the numbers from the text now keeps this model clean. So extend the view with average rating. On screen, alter semantic view, add. Add product reviews as a logical table. Keyed on review ID, add review date as a dimension. So analysts can ask for rating trends over time. And define average rating as a metric, average of rating, with synonyms rating and satisfaction. There is no clean join to the TPCH products. So reviews stays a standalone fact for now. And that one addition lets an analyst ask, what is the average product rating this year through the very same app? Handle the miss gracefully, call ask Cortex, read the message back. When Cortex cannot map a term, it signals that it does not invent SQL. So guard for it. If the type is error or there is no SQL, show a friendly warning and offer examples that do map revenue by region, orders by segment, average rating this year, and log the question into an unmapped questions table with a timestamp. Never run SQL you did not get back. Graceful failure is what keeps analysts trust after the first miss. Now make it a conversation, not a search box. Analysts ask follow-ups. Now break that down by segment. So keep a messages list in session state. Append each user, turn, render the thread as a chat transcript, and pass the prior turns back to Cortex for context. See the cap on screen, the last 6 turns only, so requests stay small and answers stay fast. That trimmed history is what turns this from a one-shot query box into something that actually feels like a conversation. Look at how governance wraps this app. 3 layers nested. The outer layer is Snowflake RBAC grant usage on the Streamlit to the analyst role. And only that role inside the app owner role runs least privilege. Select on the semantic view only, no rights. And the innermost layer, the base table policies still fire. Row access and masking policies apply to the generated SQL too. Read the amber note, the app cannot escape governance. It inherits it. Set expectations, name what Cortex Analyst will not do. It is not a forecasting engine. It answers about data that exists, not predictions. It will not read the review text paragraphs. That is part 2's agent and search job. It cannot answer about metrics you never defined. Undefined means unanswerable. And it will not write back to your tables. It is read and report by design. Say these boundaries out loud, upfront. That is what keeps stakeholders from feeling let down later. Step back. This is the part 1 capstone, the working app. You have the full stack, a semantic view, a Cortex Analyst integration, and a Streamlit chat interface. Analysts ask in plain English and the app shows the answer. The chart and the SQL, unmapped questions fail gracefully and feed your synonym backlog. The Power BI dashboard, nobody trusted can be retired. The source of truth is now the semantic model. Ship this, watch the Slack channel quiet down, then come back for part 2 and the hard questions. Quick aside before we ship 2 deep dives. They are optional. The main story still works if you skip them, but they are exactly where analyst trust is won or lost. First, the synonym mining loop, the highest leverage accuracy fix, and why it beats any model upgrade. Then why we always show the generated SQL transparency as a feature, not a leak. So stay for these if you want the app analysts actually believe. Skip ahead if you just need the build. Deep dive 1 synonyms and the loop around them. Every business term has 2 to 4 phrasings. Sales, turnover, top line all mean total revenue. Capture them all. Skipping synonyms is the classic NT pattern. It forces analysts to use your exact internal name, which defeats the whole point. So treat the list as living on screen. Mine the unmapped questions log weekly by frequency. For each recurring miss, alter the metric and set the synonyms. Then track percent mapped climbing week over week. This loop, not a bigger model, is what carries you from 70% to over 90. Deep dive 2. Why show the generated SQL? Analysts trust a chart far more when they can read the query behind it. It catches semantic model bugs early. A wrong join is obvious in the SQL. Auditors and finance love the transparency of a visible query, and it quietly turns the app into a teaching tool. Analysts learn SQL by reading it. Transparency here is a feature, not a leak. The SQL only ever touches governed objects. Hold the part 1 picture in one frame, left to right, all inside one Snowflake account. The analyst asks in English, Streamlit-in-Snowflake gives visible SQL, auto charting, and mishandling. Cortex Analyst is the grounding engine. The semantic view holds one definition per business term, and the SQL engine runs over the sample data plus reviews with result rows flowing back to the analyst. The extra small auto suspend warehouse powers it all. And notice the capability line Cortex Analyst answers what are the numbers. Part 2 adds two boxes, the agent and DBT for why and what do customers say. The Monday morning checklist 5 moves. 1. Create the role, warehouse, database and schema for the project. 2. Confirm you can query the sample data and that Cortex is enabled in your region. 3. Author the semantic view, tables, relationships, dimensions, metrics, synonyms, all of it. 4. Verify every metric against a control query before you wire any interface. And 5. Start a synonym log. You will be adding to it for weeks. And the questions people always ask before part 2. Do I need an external app? No, Streamlit-in-Snowflake is enough for an internal tool. Can two teams share one semantic view? They can, but conflicting definitions are exactly why part 2 adds DBT. How accurate is it? As accurate as your semantic model? And we measure it properly in part 2. What about PDFs and documents? That needs Cortex Search, and the agent part 2, will it replace analysts? No, it removes their weight, not their judgment. So where we landed, the first working answer. A verified semantic view, Cortex Analyst grounding, an in-account Streamlit chat that analysts actually use. The semantic model is the asset, the app is just its face, and the Slack queue is already quieting. Keep the semantic view, the reviews table, and the usage log, they carry straight into the scale-up phase. But a demo is not a system. The first hard question is coming, and the model will answer it confidently and wrongly. Next, the question that broke the demo, and how we make silent gaps surface as failures. So the demo won the room. A week later, the same VP asked one more question. Show me revenue by region, excluding returns. The app answered in 3 seconds. A tidy chart, the SQL shown America on top. And it was wrong. Nothing in the model knew what a return was. So Cortex quietly dropped the filter and answered the question it could answer, not the one that was asked. Nobody caught it for a day. The number looked right. It sat in a board deck and it overstated every region's revenue. And that is the trap. An error you fix in a minute. A confident wrong number erodes trust for weeks. Look at these two side by side. On the left, what the app said. America, $5.21 billion. On the right, the truth net of returns America, $4.93 billion. That gap is $280 million. Overstated and nobody flagged it. Here is what makes it dangerous. The app summed every line, returned once included. The truth filters the returned lines out first. But watch the charts, the bars are the same shape. America on top, Europe, then Asia, identical. Only the number underneath drifted. The eye catches nothing. This is silent wrongness, a believable answer to the wrong question. Hold this image, the rest of this act is the satisfying part. We close this gap and then we prove it can never come back quietly. So why did that happen? Confident wrong answers come from gaps, not from the model being dumb. And there are three kinds. A missing dimension, you ask to exclude returns, but no return flag is modeled. A missing metric, you ask for gross margin, but nobody ever defined it. An ambiguous synonym, the word sales maps to two metrics, so the model guesses. Each one produces a wrong shaped answer that still looks clean, and each one has a fix. Add the dimension, add the metric, disambiguate the synonyms. Hardening just means making every gap visible and easy to close. Here is the first fix: verified queries. Cortex Analyst lets you supply reviewed question to SQL pairs, and they live right in the semantic model. Look at the spec: a verified query named revenue by region year to date, the question total revenue by region this year, who verified it, the data team, and the exact gold SQL underneath. These act as gold references for a matching question. The model prefers your reviewed SQL over a guess, author a handful for your top 5 questions, and you log their accuracy. One quick note: verify the verified queries mechanism and its spec format against the current Cortex Analyst docs. The concept is stable, the exact format can move. So let's author 1. Pick a high traffic question, total revenue by region this year. Then write the exact reviewed SQL it should produce against the semantic view. Select region, sum of extended price as revenue, filtered to the current year, grouped by region, ordered by revenue. Register that pair as a verified query, so Cortex anchors to it. Then re-ask the question in the app and confirm the generated SQL matches your reviewed version. That is the whole loop. Pick, write, register, re-ask, and again confirm the registration mechanism against the current docs. Now, the gap that broke the demo: TPCH Linditum already has a return flag. The letter R marks a return line. So we model the gap as two things: a dimension return flag with synonyms like return status and returned, and better, a filtered metric, net revenue, excluding returns. Its expression sums extended price, but only when the return flag is not R, and we give it the synonyms that match how people actually asked: revenue excluding returns, net of returns excluding refunds. Recreate the view with that metric included. And now the question that silently failed maps to a real defined number. The gap is a first class testable metric. Here is the part that changes everything. A tiny accuracy harness, create an eval set table, a question, an expected value, and a tolerance per row, then seed it total revenue by region this year. America 5.21 billion, revenue excluding returns, America 4.93 billion, number of orders last quarter account, tolerance 0. The idea is simple. For each question, run the pipeline, compare the result to expected, and score pass or fail. Start with 15 to 20 questions covering every metric and dimension. This little table is the seed of the rigorous benchmark we build in part 2. Now run it. Loop over the eval set in Python for each row, ask Cortex Analyst for the sequel, execute it on the warehouse, and grab the value. Then the one line that matters is the result within tolerance of expected. Record pass or fail into an eval runs table with a timestamp so you can trend it, and at the end print the summary: so many of so many passed, and list every failure with its generated SQL. Run this after every change to the model and watch the returns question that overstated revenue by $280 million. It now fails loudly right here, instead of sitting silent in a board deck. So you have a failure. Good. A failure is a gift. It points straight at a missing metric dimension or synonym. Pull the generated SQL for the failing question and read it. References a column that does not exist, that is a missing dimension or metric. Wrong aggregation, that is a bug in the metric expression. Map to the wrong metric, that is an ambiguous synonym. Every failure classifies into one of the three gaps. Fix the model, rerun the harness, and watch the pass count climb, and keep the failing questions in the set forever. They are your regression guard. Watch this one. The word sales. To one team, it means total revenue. To another, it means order count. And the model has to guess. So don't let it. Pick one canonical mapping and document it. Then route the other phrasing to its own metric. Sales dollars maps to total revenue. Sales count maps to order count. Add a short tip in the app explaining the convention, because ambiguity resolved once in the model beats re-explaining it in every meeting. Now time analysts say this year, last quarter, year to date, those are all relative date filters. So make sure order date is a clean date dimension. Cortex can filter on with synonyms like order date and date. Then log the common time frames with verified queries. This year maps to the year of the order date matching the current year. Last quarter maps to the calendar quarter before this one.
Test the boundary cases, fiscal year versus calendar year if your org uses fiscal, and document the calendar convention. So this year is never ambiguous.
A quick word on speed. The SQL Cortex generates runs on your warehouse. Slow base tables mean slow answers. So for large fact tables, consider clustering keys on the most filtered columns. Order date is a good one. Result caching helps repeated questions. And an extra small warehouse is fine for a teaching dataset. Watch query history for the app's queries. That is where you spot a full scan. Tune the data model once and every future question benefit. Now can you actually see the app's health? Build a small view or a Streamlit page, pass rate, the average of past runs today, the unmapped questions, count your synonym backlog, and average latency trend percent mapped, and the eval pass rate week over week. And alert if the pass rate drops after a model change. Show the top unmapped questions, so the backlog is right there. Observability is what turns, I think it is accurate into, here is the number. Here is a trap worth naming, the one giant semantic model. Cramming every table and metric into a single view makes Cortex's job harder and the answers fuzzier. So scope the model to the questions one team actually asks. Multiple focused views beat one sprawling model for accuracy. Smaller, well-synonymed models map more reliably than big ones. And this previews part 2's governance. Many teams, many models, one set of definitions. So who remembers what revenue means here? The model should, every metric and dimension gets a comment explaining its business meaning. Revenue is order line revenue, the sum of extended price. Net revenue excluding returns excludes the lines where the return flag is R. Then maintain a one-page data dictionary generated from the model itself. Keep the synonym list and verified queries in version control, right beside the DDL. And when someone asks, what does revenue mean here? You point at the doc, not a meeting. Documentation is what lets the model outlive the engineer who built it. Now treat the model like code. Keep the semantic view DDL in Git and deploy it dev, then test, then prod. With the same version script tag release 1.4, here is the rule that keeps you safe. In test, run the accuracy harness before you promote. A drop in the pass rate is a failed deploy. And tag every release so you can roll back the semantic model like any code, git check out the previous tag and redeploy. Versioned semantic models are the bridge to DBT managed definitions in part 2. So look at what you can now promise. Every top question is anchored by a verified query. Gaps surface as harness failures, loudly not as silent, wrong numbers, accuracy is measured and trending not assumed. And the model is documented, versioned and promotable, which means you can stand in front of the CFO and defend any number the app produces. That is the difference between a demo and a system. Quick aside before we scale up, 6 short deep dives on running the accuracy harness well. Tolerance, multi-row checks, verified queries versus synonyms. The cost of evals, when to split a model, and the rollback drill, here is your permission slip. If you just want the story, skip to the next act, nothing breaks. But if you are the one who has to keep this harness honest in production, stay. This is the engineering detail that does exactly that. First, tolerance. Floating point sums differ in the last few digits. So revenue checks need a small relative tolerance. A tolerance of 0.01% absorbs rounding without hiding a real error. But counts are different. For a count tolerance is 0, it must match exactly. And record the tolerance per question, right in the eval set. The right tolerance is what keeps the harness honest, strict enough to catch real bugs, loose enough to avoid false alarms. Next, multi-row results. Not every question returns one number, some return a small table. So compare the sorted rows with a stable key and a parcel tolerance. Store the expected result as a small piece of JSON or a companion table. Keep these few single number checks cover most metrics cheaply, but a handful of multi-row checks catch the grouping and ordering bugs that a single number would miss. Now, verified queries versus synonyms. They do different jobs. Synonyms fix vocabulary, they map the words people use to your terms. Verified queries fix the whole question, they pin down the exact SQL. So use synonyms broadly and reserve verified queries for your top high stakes questions. Don't overuse them. Too many verified queries makes the model rigid. Together they give you both breadth from synonyms and precision from verified queries, and the verified queries double as living documentation of correct SQL. Now, cost each eval run executes real SQL on the warehouse. So keep the set small and the warehouse extra small. Run it nightly plus on every model change, not on every single commit. And cache based results where you can to avoid rescanning the same data. The harness should cost cents per run, not dollars, because cheap frequent evals beat expensive rare ones every time. Next, when to split the model. Split when two teams genuinely disagree on a definition, and split when one model grows past what a single team can reason about, but keep the shared dimensions, region, date consistent across the splits, and document which model owns which metrics. That ownership question part 2's DBT layer formalizes exactly this. Last one, the rollback drill. Tag the current semantic view DDL before any change. Then if a deploy drops the eval pass rate, you create or replace back to the tagged version and keep the eval runs history so you can prove both the regression and the fix. Practice the rollback once because a rehearsed rollback turns a scary change into a routine one. That is muscle memory under pressure. So scoreboard check. One team is now hardened gaps. Surface as failures, not silent wrong numbers. But look up here, the org-wide bar is still unlit. Accuracy around 40%, climbing toward 83. The queue at 200 a month, headed for 60. And here is why part 1 breaks at scale. Your one semantic view does not govern another team's definition of revenue. Questions that need document text the product reviews are still out of reach, and 200 requests a month need orchestration. Picture a fintech data team, 5 product teams each with its own active customer and its own revenue. Answers right only about 40% of the time. A Cortex agent will cut that queue around 70% by self-serving most asks, and DBT governed definitions will lift accuracy from 40 toward 83. The two numbers we still owe you. Carry forward your semantic view, your reviews, and your eval harness. Act 4 adds DBT's Jaffle Shop as the multi-team dataset. Count the requests, 200 ad hoc SQL pulls a month across 5 product teams, a 12-person fintech data team drowning in them. Each one takes 30 to 90 minutes. That is roughly 2 full engineers doing nothing but pulling numbers. And here is the part that stings. The answers are right only about 40% of the time because every team defines active customer its own way. Part 1 fixed this for one retail team. This is org scale chaos. Part 2 cuts the queue 70% and lifts accuracy toward 83. Look at the gap on the left. Part 1 covers one team, structured questions, one semantic view. On the right, fintech needs many teams, numbers and documents together, one shared definition of revenue, and 200 requests a month. Between them sits the thing we are missing, orchestration plus governance. One app per team only multiplies the maintenance and reintroduces the very inconsistency we are fighting. The bottom line, a Cortex agent to orchestrate, ADBT semantic layer to govern. That is part 2. So what is a Cortex agent? Picture an orchestrator sitting under the question. It reads what you asked, then plans which tools to call below it. 3 tools: Cortex Analyst for structured metrics governed by DBT Cortex, search for unstructured text like reviews and tickets, and an optional custom tool. It hands back a synthesized answer plus the evidence, the SQL it ran, the documents it pulled, read the orange note, the agent plans, which tools to call. It does not invent data. Think of it as the part 1 app's brain generalized. Meet the two tools the agent will lean on. Tool 1, Cortex Analyst over ADB covered and semantic model. It answers the number questions. Tool 2, Cortex Search over review and ticket text. It answers the why, the what are they saying. So routing is simple. Revenue by product goes to analyst, top complaints goes to search, and a blended question. It calls both, then synthesizes one answer. One note on screen: confirm the agent tool configuration syntax against the current docs before you build. Meet the dataset we will build on: DBT's Jaffle Shop, customers' orders and payments for a fictional cafe. On the left, 3 staging tables: STG customers, STG orders, STG payments. They flow right into 2 Marts dim customers with customer ID, name, first order, and order count, and FCT orders with order ID, customer ID, amount, status, and order date. It is tiny, well understood, and ships with DBT. That simplicity is the point. It lets us focus on the semantic layer and the agent, not on wrangling data. These marks back every metric we are about to define. Morning, watch the load montage. The full script lives in course resources. On the Snowflake side, stand up the landing zone once, a database, a schema for analytics, and an extra small auto-suspend warehouse for the transformations. Then, from the DBT project, DBT seed loads the raw CSVs. DBT run builds the staging tables plus dim customers and FCT orders. DBT test validates not null, unique, and relationships. Verify the marks exist with sensible row counts. We are not reading setup line by line. Point your profile at Snowflake and move straight to defining governed metrics. Here is the DBT semantic layer in one picture. At the bottom, your real models, FCT orders, dim customers. Above them, semantic models in YAML entities, dimensions, measures. Above that, metrics in YAML, total revenue, active customers, average order value, and one arrow flows up to every consumer. BI tools, the Cortex Agent, notebooks, read the side label, define once in YAML, govern it in Git, consume it everywhere. This is the org-wide answer to part 1's 5 definitions of revenue problem. Look at the YAML, ADBT semantic model for orders. It declares the model it sits on, ref safety orders, then entities, the join keys, order as primary, customer as foreign, then dimensions, the group buys order date by day, status as categorical, then measures the aggregatable building blocks, revenue as a sum of amount, order count as a count of order ID, entities join, dimensions slice, measures aggregate and confirm the exact keys against the current DBT docs before you ship. Now turn measures into named business numbers. Read the metrics YAML, total revenue, a simple metric, the sum of the revenue measure labeled with a description that says net revenue from completed orders and average order value, a ratio total revenue over order count. Every metric carries a label and a description that is the governed business definition written down. And because they live in DBT, the metrics are code reviewed, tested and versioned. This is the single source of truth that lifts cross-team accuracy. Here is the one that mattered. Most active customers defined once and for all. Remember the 40% problem. It traced to 5 different definitions of active customer. So the teams agreed on one. Read the description in the YAML, a customer with at least one completed order. In the trailing 90 days, the filter pins it down order status equals completed and order date within the last 90 days. Encode it as a governed metric, and every team and the agent use the same logic, one definition governed in Git. That is the core of the accuracy lift. So how do these DBT metrics reach Cortex? Follow the path on the left. The DBT project in Git, semantic models and metrics YAML. The source of truth and arrow sync or generate into the middle a Snowflake side semantic model that mirrors the DBT metrics. And on the right, Cortex Analyst, the agents tool, resolving metric names into governed SQL. Read the orange note. DBT owns the definitions, the Snowflake model only mirrors them. And verify the supported integration path against current docs, because this one moves. One definition flows from Git all the way to the agent. Now stand up the agent's text tool, Cortex Search over the review text. Read the SQL, create or replace Cortex Search service, Jaffle review service. On the review text column, attributes for product and review date. So the agent can filter an extra small warehouse, a target lag of 1 hour, and the query that feeds it, review text, product and date, pulled from the customer reviews table. This is what answers what are users complaining about. Confirm the create Cortex Search service, syntax and the option names against the current doc. Now assemble the agent. Step 1. Create it and register its two tools, the analyst, DBT governed, and the search service. Step 2. Give it an instruction prompt, describe the domain and when to reach for each tool. Step 3. Watch how it plans. A number question routes to analyst, a text question to search, a blended one to both. Step 4. Test one of each and inspect the tool calls it actually made and confirm the agent creation and tool registration syntax against the current docs. So let's hand it the hard one, the blended question that no single tool can answer alone. First, watch the single tool fail. Ask Cortex Analyst alone revenue dropped for mobile last month. What are customers saying? It returns the number, revenue down 12% and then it stops. It cannot say a word about why because the why lives in review text it never sees. Now give the same question to the agent at the top. The question it branches into two calls. Left Cortex Analyst, the revenue trend down 12% with SQL, right Cortex Search, the top theme app crashes on checkout with 3 review snippets. Both feed the synthesis box revenue down 12%, leading complaint checkout crashes, 14 reviews. One question, two tools, one governed answer. Before, that was two Slack requests and a day of waiting. So why does governance actually lift the number? Before, each team's active customers SQL differed, so cross-team answers conflicted right about 40% of the time. After 1 dbt metric definition means every answer runs the same logic. The agent cannot drift because it resolves names to governed metrics, not to ad hoc SQL it invents, and search grounds the qualitative answers in real review text, not model guesses. Governance plus grounding, that is what moves accuracy from about 40 toward 83. Picture the meeting that ended early. A product lead asks the agent one thing: how many active customers does mobile have and why are they churning? The number resolved to the one governed DBT metric. No debate, no argument about whose definition was right. The churn themes came from search over the support tickets, grounded in the real text. A meeting that used to spawn 3 SQL requests ended with a single agent answer. And notice what governance did. It did not just improve accuracy, it removed the argument about definitions entirely. Now the NT pattern, the ungoverned agent and the agent raw table access, and you invite the same inconsistent definition problem right back in. Always route its structured answers through governed metrics, never raw SQL on raw tables, because without governance, the agent is just a faster way to be wrong, and search must point at curated, relevant text. Not every table that happens to have a string column. The agent amplifies whatever you feed it. So govern the inputs. Let's talk cost and latency plainly. Each agent answer may fire several tool calls plus reasoning steps, so it is not free. Keep the warehouses extra small and scope the search service to relevant text only. Cache the common ones. Because the same 5 blended questions keep recurring, monitor credits the way part 1 did. An agent should save money, not open a new spike. And the latency, most of it comes from cold warehouses and multi-tool plans. Budget a few seconds and move on. Here is a fork in the road. An optional aside, 6 short deep dives on operating the agent well. Before we go prove the lift agent planning. DBT test as accuracy guards, search relevance, keeping DBT as source of truth, multi-team onboarding and agent security. If you are shipping this to 5 teams, stay. These are exactly what separate a demo agent from one people can lean on. If you only came for the proof, skip ahead to the scoreboard, you will lose nothing in the storyline. Deep dive 1: how the agent plans. It reads the question alongside your tool descriptions, then plans the calls. So those descriptions are critical. They are what tell the agent when to use each tool. Write them like API docs, what this tool answers, what inputs it needs. Then test the plan on edge questions and confirm it routes correctly. Here is the lesson: most routing mistakes are description problems, not agent problems. Deep dive 2 DB tests as accuracy guards. Look at the schema YAML. On FCT orders, order ID gets unique and not null. Customer ID gets not null plus a relationships test back to dim customers. Amount gets not null. And status gets an accepted values test. Completed, returned, pending. Because a metric is only as trustworthy as the model under it. Add tests on the metric inputs. So a bad upstream change fails the build. Run DBT test in CI before any metric ever reaches the agent. Clean models plus governed metrics. That is the foundation of the lift. Deep dive 3: search relevance. Scope the service to genuinely relevant text, reviews, tickets, not everything you own. Use attributes like product and date so the agent can filter what it retrieves. Set a sensible target lag so search stays fresh without over refreshing, and test retrieval with known queries before you trust it inside the agent. Garbage text in yields garbage answers out. So curate the corpus. Deep dive 4: keeping DBT the source of truth. Trace the change flow left to right. Edit the metric YAML in a pull request. DBT test in CI. Sync to the Snowflake semantic model. Run the accuracy benchmark. Then deploy to the agent and see that red arrow. If the benchmark fails, it loops back to the edit, fail, then fix, read the rule under it. The DBT repo is the only place definitions change. That discipline is the whole governance story in one line, and it is exactly what prevents the drift that caused the 40% problem. Deep dive 5: onboarding more teams. Each product team contributes its metrics to the shared DBT project by pull request. The shared dimensions like date and customer are owned centrally, so they stay consistent. Conflicts, two definitions of revenue, get resolved in review, not in production, and the agent automatically inherits every governed metric the teams agree on. Onboarding a team is a pull request, not a new app. Deep dive 6 security. The agent runs under a role, and that role's grants bound everything it can read. Row access and masking policies on the DB tmarts still apply to the agent's answers. The search services respect the privileges on their source tables, so scope the agent's role to the governed marts and the curated search corpus, and nothing more. The rule is short. An agent cannot leak what its role cannot see. Step back and check the scoreboard. We built the machine that should light up both numbers, governed DBT metrics, and a Cortex agent answering blended numbers and text in one shot. But read the orange banner, claimed not yet proven. Both bars are hatched and pending accuracy, 40 toward 83, Q 200 a month toward 60. We loaded Jaffle Shop, defined the governed metrics, and watched the agent answer with analyst and search together. And we argued governance lifts accuracy and cuts the queue. But arguing is not proving. Claims without measurement are just marketing. So the next act puts both numbers on trial, a version benchmark, ungoverned versus DBT governed, and a request log measuring the real cut. The cliffhanger: does DBT governance actually move the number, or does it just feel better? So we made a claim that DBT governance lifts answer accuracy from about 40% to about 83%, and a claim without a benchmark is just a slogan. So this is the claim on trial. We build a test set of real fintech questions, each with a vetted gold answer. Then we score the agent two ways: ungoverned generation against DBT governed metrics, and we report the honest lift, including the questions governance does not fix. Here is how you design a benchmark that does not lie to you. Pull the questions from the request log, the ones real teams actually asked, not ones you imagined. Give each one a gold answer, agreed by a human expert. Mix the types, a structured one like active customers in the last 90 days, a text one like the top complaint, and blended ones. Score numbers by tolerance, text by whether the right theme was retrieved, and include hard questions you expect to fail. An honest benchmark has some red in it. Look at the table behind it. Every question carries a type, numeric, text, or blended, a gold value or a gold theme, and a tolerance. Tolerance 0 for counts, about 1% for revenue. Tag each row with the metric it exercises, so you can see which definitions matter most. Keep it to 30 or 50 questions, meaningful and cheap to run, and version it in Git right alongside the DBT metrics. This little table guards every future change. Condition A is the baseline. Let the agent generate SQL straight against the raw Jaffle tables with no governed metrics. So there is no shared definition of an active customer. The model just guesses every single time. This is the fintech starting point, the one that scored about 40%. Run every benchmark question here. Record pass or fail. This is the before. This is what we are trying to beat. Condition B is the treatment. Now the agent resolves a metric name to its governed DBD definition. Active customer means the one agreed 90-day completed order definition. Every time, no guessing. Cortex Search still grounds the text answers in the curated corpus. And here is the discipline. Same questions, same agent. The only thing that changes is governance, one variable isolated. Watch how a numeric question gets scored. Compare the agent's number to the gold value. Inside the per question tolerance, counts have to match exactly. Revenue allows a tiny relative wiggle, about 1%. And we record the value it got, whether it passed, and the SQL it generated on every failure, because a numeric failure almost always traces back to a definition mismatch, which is exactly what governance fixes. Now the text and blended ones. For a text question, we just check whether the expected theme surfaced in the retrieved evidence. Gold theme, lowercase found inside the snippet. Deterministic, so the benchmark repeats. For a blended question, both halves have to pass the number and the text, and we record which half failed, because that tells you exactly which tool to go fix. Here is the whole sweep. Running. Loop over the benchmark set. Ask the agent each question in both conditions. Score it by type and insert the result tagged with the condition. Then aggregate the pass rate per condition and per question type. Run it on a tiny warehouse. The full sweep costs cents. And because it reruns on demand, this is both your regression tool and your proof. And here it is, the scoreboard from Act 1 finally lit on a real run. Ungoverned about 40% overall, DBT governed about 83. Break it down by type and the story is clear. Numeric jumps from 35 to 90, text barely moves 60 to 70, because search already grounded it. Blended climbs from 30 to 80, and we report the failures too, not just the headline. That is the accuracy half of the promise, proven the Q half is next. So why is the lift mostly in the numbers? The text answers were already grounded by Cortex Search, governance barely touched them. But the numeric answers hinged on definitions, and definitions are exactly what DBT metrics standardize. Blended questions inherit the lift because their number part finally agrees. The benchmark localizes the value, governance pays off precisely where definitions vary. That is the kind of insight a slogan can never give you. Look at what still fails. This query pulls every question the agent missed in the governed condition. Some fail in both, usually a metric nobody has defined yet. A few fail on ambiguous phrasing the synonyms do not cover. Others fail because the corpus simply lacks the text, a coverage gap, and each one becomes a concrete backlog item. Define a metric, add a synonym, extend the corpus. An 83% benchmark with a clear backlog beats a vague claim of much better. Now we turn accuracy into a smaller queue. Every ad hoc request lands in an inbox. And the first question is, can the agent answer this with high confidence? Yes, it auto answers and logs it. No human touched it. No, it escalates to the data team, carrying the context along. That confidence gate decides the split and watch the band at the bottom before 200 a month to humans. After about 60 or 70% cut. Here is how you prove that 70% track the human handled ad hoc requests per month before the agent and after. This query counts them total human handled, auto answered, and the auto answer percentage. The cut equals the share the agent answered acceptably. Validate a sample of those auto answers monthly to keep the gate honest, and always report the queue and the accuracy together. Speed without accuracy is a trap. The request log is the receipt. This is the gate itself. Auto answer only when the tools came back with grounded evidence, a real resolved metric, real search snippets. An unmapped metric or an empty search counts as low confidence and it escalates. For the question types where governed accuracy is high, let it auto answer freely. Where accuracy is low, route to a human even if the agent produced something. This gate is how you shrink the queue without ever shipping a wrong answer. And this is the engine that keeps it improving. Every escalated question is a candidate, a missing metric or a gap in the corpus. You add the fix in DBT as a pull request, rerun the benchmark, confirm accuracy held or rows, then move that question type from human over to auto, coverage grows, the queue shrinks, accuracy climbs, round and round. This loop is what carries you past 83% next quarter. Now the trap, you could auto answer everything and cut the queue clean to zero and ship wrong answers at scale. But the whole point of governance is accurate self-service, not merely fast self-service. So always pair the queue metric with the accuracy benchmark. If accuracy dips, tighten the gate, even if the queue grows back. Because trust, once you lose it to a confident wrong answer, is expensive to rebuild. Step back and see the whole of part 2. The DBT repo in Git holds the governed metrics, the single source of truth. It syncs into the Snowflake semantic model, and Cortex Search indexes the review and ticket text. The Cortex Agent orchestrates both, the analyst for numbers, search for text behind a confidence gate. Out one side, the queue router, out the other, the accuracy benchmark and the request log, one Snowflake account, one governed repo. Every box governed, measured, improvable. But here is the hard truth. The demo is not the system. The Cortex Agent benchmarked at about 83% on a laptop. Then a product team hit it on Monday and it broke. A search service had gone stale. A metric pull request had not synced and nobody owned the on-call. A working demo and a production system are genuinely different animals. So this last stretch turns the build into something 5 teams rely on every day. Definitions deploying automatically, freshness scheduled and visible, every answer logged, access role governed, an owner and a runbook in place. So we wire continuous delivery for the definitions. Every metric change is a pull request against the DBT repo. The only place definitions change. The pipeline runs DBT build, DBT test and accuracy benchmark before anything merges. On merge, a deploy job syncs the Snowflake semantic model from those definitions. And a failed benchmark blocks the deployed definitions, never regress silently. A green benchmark is the merge gate, that is the discipline that stops accuracy drifting back toward 40. Next, freshness. The DBT models rebuild on a cadence. hourly, daily through your orchestrator or DBT jobs. And a Cortex search service refreshes by its target lag. Here set to 1 hour, match the freshness to the question, near real time for ops, daily for trend work, and surface the last refresh timestamp right in the app. So a user knows how fresh the answer is. Confirm the current scheduling options against the docs. They move. Now you watch it run. Track per day questions asked. The auto answer rate, the escalation rate, P95 latency and credits. Alert when the auto answer rate drops, that is a coverage regression, or when latency spikes, that is a warehouse or tool issue. Rerun the benchmark nightly and alert on any accuracy regression. And watch for a stale search service silent staleness is the classic production failure. One dashboard turns is it healthy into a glance, not an investigation. And the agent never escapes governance. Picture three rings. The outer one, RBAC, the agent runs under a dedicated role scoped to the governed marts and the curated corpus. Inside that, row access and masking policies on the DBT marts. They apply to every answer it gives automatically. At the core, Corpus Agent, PII masked or excluded before anything is indexed. And off to the side, the audit trail, the request log joined to user identity. So you know who asked what. The agent inherits governance, it cannot bypass it. This is Corpus Hygiene in SQL. Review and ticket text is full of names, emails, account numbers. So before any of it enters a Cortex search service, you mask it, build a sanitized view, regular expressions, strip the emails and the long digit runs, and you keep only what is searchable. Respect retention too. Do not index text you are required to purge. Then point the search service at the sanitized view, never the raw table. For a fintech, this step is not optional. Now you scale to a second team. Start with the team whose questions you already benchmarked. They add their metrics to the shared DBT repo through a pull request, but the shared dimension stays centrally owned. Add the real questions to the benchmark before you turn on auto answer for them. Then confirm overall accuracy still holds as the definitions merge in. Onboarding a team is a pull request plus a benchmark pass, not a new app, not a new model. Two teams will define a word differently, that is the whole problem. Team A says revenue means gross. Team B says revenue means net of refunds. So you ask, same business meaning. If yes, one governed metric, total revenue, documented. If no, two clearly named metrics, gross revenue and net revenue, explicit, no guessing. You resolve it in pull request review recorded in Git, never in production with diverging SQL, and the agent never silently picks between them. Scaling search is the same instinct. Each team has its own text corpus, reviews, tickets, docs. So create a scoped search service per corpus rather than one giant index. Register the relevant services as agent tools, each with a clear description. Scoping keeps retrieval relevant and it respects per team access boundaries, and those tool descriptions are what tell the agent which corpus answers which kind of question. And you govern the cost of the whole thing. Tag the warehouses and queries so the agent search DBT and the benchmark each show up as attributable. This roll up sums credits per component per day straight out of account usage a query history. Right size the warehouses and extra small handles, a teaching or early production load, cache the common questions, cap the result sizes so nothing runs away. Then present the system cost against the roughly 1.4 engineers of ad hoc work it gives back. Here is the runbook, paste ready triage. Auto answer rate dropped. Check search freshness and the recent DBT deploys. Wrong numbers. Confirm the latest metric pull request actually synced, then rerun the benchmark. Slow answers. Check warehouse cold start and the multi-tool plans empty text answers. Check the search service status and the corpus load. Each symptom maps to one probe. A one-page runbook turns a 2 AM page into a checklist, not a panic. And when a definition goes bad, you roll it back fast. A metric pull request that drops the benchmark has to be revertible in minutes. So tag every deploy to its DBT git commit, revert the commit, resync done. Keep the benchmark history so you can prove both the regression and the fix. Then tell the affected teams the corrected number. A rehearsed rollback is the difference between an incident and a non-event. And when a definition must change for real version, it do not mutate it. Introduce revenue version 2 alongside revenue. Migrate the consumers, then retire the old one. Announce the change and the cutover date to all 5 teams, and have the benchmark cover both versions through the transition. Because a number should never change meaning without notice. Versioning is how you protect trust. Once the core holds, you extend the agent. A forecasting metric, an anomaly check, a doc search, add them once the foundation is stable. Each new tool needs a clear description and benchmark questions before it goes live. Add those questions, confirm nothing else regresses, and resist tool sprawl. Every tool the agent has is one more routing decision it can get wrong. Grow capability deliberately gated by the benchmark every time, and you teach people to ask well, publish a short guide, include a metric like revenue, a dimension like by product, a time frame like last month, seed each team's channel with example questions that map cleanly, mine the escalation log for the phrasing gaps, and add synonyms from the real misses. Run a 30-minute onboarding per team. Adoption is taught, not assumed. Better questions in means better answers out. Enablement is part of accuracy. Now put it in front of leadership, both lines on the scoreboard, lit and defended. The Q 200 a month down to about 60, a 70% cut. Accuracy about 40% up to about 83. Against a known system cost, less than the value of 1.4 engineers, report 3 numbers monthly, Q accuracy cost, and show the trend, not a single snapshot. Tie it to the business case, engineers return to roadmap work, and include the backlog as the path to next quarter's gains. And here is the slow trap. The 40% problem comes back the moment definitions drift out of the DBT repo. So forbid out of band metric edits on the Snowflake side. The repo is the only source. Keep the benchmark as a hard merge gate forever, not a launch week ritual. Periodically audit that the Snowflake semantic model still mirrors DBT. Governance is a habit. The day you stop enforcing it, accuracy starts falling. Here is the complete operating picture. In 3 bands, govern the dbt repo of metrics, the CI benchmark gate, the deploy sync, serve the semantic model, and search services feed the Cortex agent behind its confidence gate into the queue router, operate the request log and nightly benchmark rollup into the ops dashboard and the exec scorecard, and wrapping all of it RBAC, masking, and PII hygiene. One Snowflake account, one repo, 5 teams, every box with an owner, a schedule, and a rollback. A quick deep dive out of scope questions, and feel free to skip ahead if you have got the gist. Some asks are genuinely outside the data. Legal advice, future predictions. The agent should decline and route to a human rather than invent an answer. Maintain an explicit out of scope list in the instruction prompt and log these so you can decide whether a new tool or data source is warranted. A confident I cannot answer that protects trust more than a wrong guess ever will. Another short aside, measuring real adoption, the auto answer rate is supply, the weekly active askers is demand. Track both. A high auto answer rate with very few askers means the tool is not trusted yet. Survey the teams quarterly. Do they reach for the agent before Slack, and tie adoption to the queue metric. Falling Slack pings is the real signal. Adoption, not capability, is what finally retires the request queue. Run down your production checklist. Continuous delivery via DBT repo into the benchmark gate into a synced semantic model. Freshness scheduled and visible, and PII masked before indexing. The ops dashboard and exec scorecard live with nightly benchmark alerting. The agent role scope, policies enforced, the request log auditable, and an owner, an on call, a runbook, and a rehearsed rollback all in place. That is what production means here. And you do not start from scratch. The course resources for part 2 ship with it all. The Jaffle Shop DBT project, semantic models, and the governed metrics YAML, active customers, total revenue. The Cortex Search Service DBL and the agent assembly script, verify it against the current docs, the benchmark set, the scoring Python, and the results rollup. The request log BBL, the QCut and confidence gate queries, and the improvement loop runbook. One optional aside before we close. These are the deep dives that keep the benchmark and the rollout intellectually honest. Building the weighted gold answers, being statistically honest about a small test set, declining the out of scope questions, and measuring real adoption. Optional, yes, but this is the difference between a benchmark leadership trusts and a slogan they do not. So, where do the gold answers come from? From a human expert running vetted SQL or reading the source text for a numeric question. The gold is the control query result on the governed model. For a text question, the gold theme is the human agreed dominant complaint. And you store who vetted each answer and when provenance vetted gold answers with provenance. are what make the benchmark credible to leadership. So here is what you now own. Not a recap, a handover, a 5-step operating model you can run on Monday and defend to a CFO, ground it in a semantic model, govern it with DBT metrics, orchestrate it with a Cortex agent, measure it with a benchmark and a request log, operate it with continuous delivery, monitoring, security and a rehearsed rollback. And what you can now promise out loud, about 83% accuracy on a versioned benchmark, a roughly 70% smaller ad-hoc SQL queue, about 1.4 engineers of fetch work returned to the roadmap. The durable asset is the governed metric layer, not any single app. Your analysts ask Snowflake, your engineers build instead of fetch, so pick one next step. Now, go deeper on the foundations in AY Ready Data Engineering Course 3005 or master the governance layer in DBT and Snowflake Analytics Course 1013, link in the description. Now, go build it.